Hi, welcome all of you to the module 3 of SRWE course, which is VLANs. So VLANs actually stand for Virtual Local Area Networks. We all have come across the term LAN quite a few number of times and must have a good understanding about local area networks. Then what does this virtual adjective mean? VLANs actually enable a group of devices belonging to multiple networks, even when they are physically separated, to be combined into one logical network. These VLANs are created at layer 2 to reduce or even eliminate broadcast traffic. VLANs make network management easier and help to improve the performance of busy and large networks. The network administrator can organize VLANs by location, types of users, types of devices, or whatever category is needed at the time. This module is going to cover the concepts related to creation, configuration, and verification of VLANs in a network. So let's find out how to proceed. These are the different topics that we are going to cover in this particular module, where we are going to provide an overview of VLANs first, and then we are going to talk about VLANs in a multi-switched environment, where we learn how a switch forwards frames based on VLAN configuration, and how do you configure VLANs, how do you configure VLAN trunks, what do you mean by trunk, what is the purpose of a trunk, and finally we will come across the DTP protocol, which is the dynamic trunking protocol, why it is used. Okay, so let's get going with this. And if you see here, what the first is the overview of VLAN. Now, here what we are talking in the earlier introduction when I was saying about VLANs are, VLANs are primarily created to divide the broadcast domains, to partition the broadcast domains. VLANs provide segmentation and organization flexibility in a switch network. A group of devices within a VLAN communicate as if each device was attached to the same cable. As I told you, you need not have the devices connected physically with the same cable or physically to the same network. Even then, I can create VLANs because VLANs are logical in nature rather than physical in nature. So we base our VLANs on logical connections rather than physical connections. Now you might ask me, why should we do this? What is the need for going to VLANs? Now there are many characteristics and benefits going towards VLANs. Let me show you those things. First thing is, it gives you more manageability for the organization. The broadcast, multicast, and unicast are isolated in the individual VLAN. Each VLAN will have its own unique range of IP addressing, and most primarily you have smaller broadcast domains. So what are the benefits of going for VLANs? So these are all the benefits which are highlighted over here. The first thing is smaller broadcast domain. Now I keep on saying smaller broadcast domain. The main thing here is you have to understand the broadcasts are going to create a lot of network traffic and they will degrade your network performance. So if you divide the broadcast domain, automatically the broadcasts are limited to that particular VLAN only. They don't simply propagate throughout the entire network. So that is what we mean by reducing the broadcast domain as an advantage. Next thing is improved security. Now, when you do a VLAN configuration, the users belonging to the same VLAN can communicate, and they will not be able to communicate with other cells. So security will be better. Improved IT efficiency, because VLANs can group devices with similar requirements. Maybe if you take college as an example, you can have different groups, including students, faculty, administration, like that. And we can name the VLANs also to identify them easier. Reduced cost, as I said, rather than if you want to create the segmentation of networks using physical means, you need to buy a lot of switches, cabling, all the cost will be involved. But here, one switch is sufficient if you can implement VLAN configuration. So there is considerable reduction in the cost involved. Better performance, obviously smaller broadcast domains reduce traffic, which improves bandwidth, and simpler management. Now, when you divide the large networks into smaller groups, management of these smaller networks will become much more easier. Now, what are the different types of VLANs we have? The default VLAN on a Cisco switch is VLAN 1. All the ports of a switch are assigned to VLAN 1 initially. It's a default. The VLAN 1 is the default VLAN. It is a default native VLAN. It is a default management VLAN. It cannot be deleted or it cannot be renamed. Basically, if you don't set anything else, VLAN 1 stays the default one for all your ports and for the remaining native and management VLANs also. But usually when we start working with VLANs, it is a good procedure to use other VLANs rather than VLAN 1 for the management and native VLANs. We'll see. So if you see here, there is a small show command, show VLAN brief. It is showing that the VLAN number is 1. It is the default one. It is active. It is always active. And if you see all the ports, F0 by 1, 2, 3, 4, 5, 6, and the 2 gigabit ports here are all assigned to VLAN 1 by default. Now, the next one is data VLAN. So data VLANs are the VLANs that are configured to separate user-generated traffic. They are referred to as user VLANs because they separate the network into groups of users or devices. So we call it as a data VLAN. Generally speaking, VLAN 1 is a default data VLAN because all the interfaces of a switch are assigned to this particular VLAN. The next type is called as native VLAN. Now, to understand native VLAN, usually when a switch supports multiple VLANs, the whatever frames it is receiving should be tagged with it. Usually we used to have some stickers on notebooks identifying what notebook it is, whether it is a max classwork or max homework, social classwork, social homework. Similarly, we have the procedure is called as tagging. Usually, each and every frame passing through from a VLAN will have its VLAN ID. Sometimes the switches might need to forward untagged traffic also. Generally, the 802.1q trunk port places this untagged traffic on the native VLAN. It is also the VLAN 1 is the default native VLAN on a Cisco switch, and when we need to configure it, we will be assigning a different number to it. Now, the third one is management VLAN. This management VLAN is a kind of data VLAN which is configured specifically for network management traffic, including SSH, Telnet, HTTPS, HTTP, and simple network management protocol SNMP. VLAN 1 is configured on a layer 2 switch as the management VLAN default, and if needed, you can change it also. Other than these VLANs, there is another VLAN called as voice VLAN. Usually, when you set up a voice or IP phone, you need to set up a voice VLAN. The reason why we need to have a separate VLAN is voice traffic requires quality of service, that is high QoS priority, assured bandwidth, the ability to avoid congestion, and most importantly, the delay should be less than 150 milliseconds from source to destination. Thereby, when you want to implement a voice VLAN, the entire network must be designed to support voice. If you check it out here, there is a switch, there is a PC which is connected to this, and there is also an IP phone which is connected to the same port F0 by 18. So this port, you can see VLAN 150 is designed to carry voice traffic. The student computer PC5 is attached to this secure IP phone, and the phone is attached to switch S3. So PC5 is in VLAN 20, which is used for student data. What you have to understand, this port F0 by 18 can be configured to support both voice traffic from VLAN 150, including this IP phone, and also traffic from VLAN 20 to which this PC5 belongs to. Okay, we'll discuss more about these things, how to configure them. Let's talk about VLANs in a multi-switched environment. What do you understand by the multi-switched environment? Here, what we do is we come across the term called as trunks. What is a trunk? A trunk is a point-to-point link between two network devices that carries more than one VLAN. To understand it better way, check out this diagram. Now you have one switch S2 here, another switch S3 here. Give me 1 second. S3 here. Now there you go. S2 is here, S3 is here. Now S2 supports 3 VLANs, VLAN 10, VLAN 20, VLAN 30. Similarly, S3 also supports VLAN 10, VLAN 20, and VLAN 30. For PC1 to communicate with PC4, this traffic has to pass through S2 to S1 and then to S3 again. In this case, the links between S1 and S2 and S1 and S3 are called as trunks because they have the ability to carry traffic belonging to different VLANs. When VLAN 10 traffic or VLAN 20 traffic or VLAN 30 traffic, all of these traffic should pass through these two paths only. So these two links are called as trunk links. You have to set them up as trunk links. Now, What are the trunk functions? It allows more than one VLAN. I just shown you 10, 20, 30. All these three are allowed, and any untagged traffic also it should allow. Extend the VLAN across the entire network. So not just within the switch, they can move from one point of network to another point of network. By default supports all VLANs, and you have different commands to change that also. And supports 802.1q trunking. We'll talk about that trunking and the 802.1q encapsulation later on. So this, as I said, in this particular example, the highlighted links between switches S1 and S2, S1 and S3 are configured to transmit traffic coming from these three VLANs and also 99 native VLAN. I told you what do you mean by native VLAN. If the traffic does not belong to any one of these VLANs, if it is untagged traffic, this should allow the untagged traffic also. For that, we define the native VLAN, and we are going to assign a number ID as 99. So this network, for this to happen, for the communication to take place, it cannot happen without you guys defining the VLAN trunks. Okay, this is what a trunk means. Now, let's said a VLAN trunk does not belong to a specific VLAN. It does not belong to anything. It is a conduit for multiple VLANs between switches and routers. So this trunk, if I say what is the VLAN for it, it does not belong to one specific. It simply allows traffic belonging to different VLANs. Okay. Now, networks without VLANs, I just told you. If you don't have a VLAN, usually now if one device is sending a broadcast message, this broadcast message will be received by everybody. So huge amounts of traffic will be spreading through the network. Now, what if you have a VLAN? If you divide them into logical LANs, what happens is these VLANs, because without a layer 3 device, the devices belonging to different VLANs will not be able to communicate among themselves. This broadcast traffic, whichever is there in the earlier picture, it is now confined to that VLAN only. You see, if the traffic is distant from VLAN 10, it is only received by the VLAN 10 devices only. Now, if you hear PC1 sends a broadcast traffic, this PC1 belongs to VLAN 10. So whatever devices are here that belong to VLAN 10 only will receive the broadcast traffic. Earlier, this broadcast traffic is actually received by everybody. Okay, so this is what it is actually. This is a layer 2 broadcast. How do you identify VLANs? As I just told you, how do you identify VLANs, or how it is being done? Now, whenever Ethernet frames are placed on a trunk, information about the VLANs to which they belong must be added. In our Ethernet frame format, you don't have a space for this. So this process, which is called as tagging, where you mark each frame with the VLAN ID that it is generated from, it is actually it is called as tagging, and it is accomplished by using the IEEE 802.1q header, and it is specified in the IEEE 802.1q standard. This header is 4 bytes. You see here, this header is 4 bytes. It is also called as a tag. This is the 4 bytes, 2 bytes, 3 bytes, 1 bit, and 12 bits. This is your normal Ethernet frame format. When the tag is created, the FCS must be recalculated because now we have made a change to it. When sent to the end devices, this tag will be removed and the FCS will be recalculated back to its original value and then forwarded to the upper layers. What are these 4 bytes? What is information that will have? The first one is a type field. This is referred to as tag protocol ID or TPID. Next comes user priority, which is 3 bits. It supports or what type of level or service implementation. The third one is called as CFI, canonical format identifier, which can support token rings or Ethernet frames. Last field is your VID field, which is the VLAN ID field, which is 12 bits in length, and it can actually support up to 4096 VLANs. So this is your tag. Usually it is 4 bytes in length, and this is called as tagging. It is pretty much simpler if you just place name tags on different things to identify what they are. Similarly, any frame originating from a device belonging to a particular VLAN has to mark that frame with that VLAN ID. Only then the switches on and route will be able to understand and which VLAN does this packet or does this frame belong to. Okay, so native VLANs and 802.1q tagging. I spoke to you that the IEEE 802.1q standard specifies a native VLAN for trunk links, which defaults to VLAN 1. Now, whenever an untagged frame comes on a trunk port, it is assigned to the native VLAN. Now, usually in the earlier slide, I told you about tagging process. Tagging process means you need to add a tag or an ID for each and every frame belonging to a VLAN. Now, what if a frame comes in with no tag? It doesn't belong to any VLAN. Such traffic is always assigned to native VLAN. The management frames that are actually sent between the switches is an example of traffic which does not belong to any, it's an example for untagged traffic. If the link between two switches is a trunk, the switch sends the untagged traffic on the native VLAN itself. Now, to discuss more, the basics of 802.1q trunk, tagging is typically done on all VLANs. The use of native VLAN actually was first designed for legacy use in case when you are talking with hubs. Unless you specifically change it, VLAN 1 is the default native VLAN. Both ends of the trunk link must be configured with the same native VLAN. The number cannot be different from one end and the other end. Each trunk is configured separately. So it is possible to have a different native VLANs on separate trunks. We will discuss about this, and I'm going to create videos on creation of VLANs, creation of trunks using your packet tracer activities. Do check them out so that you will get a hands-on experience and you will be able to understand better about the trunking and the VLAN configurations also. Voice VLAN tagging. Usually the voice over IP phone is a 3-port switch. The switch will use the CDP to inform the phone of the voice VLAN. The phone will tag its own traffic and set the COS parameters. COS is cost of service. It is like quality of service. The phone may or may not tag frames from the PC. Now, usually there you go. The voice VLAN is tagged with the COS priority value. Access VLAN can also be tagged with layer COS priority value. And access VLAN is not tagged when there is no priority value. This is how it usually happens with voice traffic. And we have separate commands to create voice VLANs also. We will see in course of this particular PPT. Now, if you want to verify how it is being done, if you type in show interfaces F0/18 switch port, it will show us both the data and voice VLANs assigned to the interface. I have shown you the example earlier. If you see here, F0/18 access mode VLAN 20 student, which is the PC5 that is attached to the same port. And similarly, it is also showing the voice VLAN 150, which is actually done by the voice or IP phone. Okay. So how do you configure VLANs? How do you configure them? What are the different commands that is to be used? First things first, what are the VLAN ranges? Now, different switches supports different numbers of VLANs, but usually there are two categories. The first one is normal range VLANs, which are numbered from 1 to 1005. And the second category is extended range VLANs, which are numbered from 1006 to 4094. Now, this is a small comparison. Usually, if you check it out here, these 1002, 1003, 1004, 1005, they are reserved for legacy VLANs and they support the FDDA, token rings, all the older ones. And all the normal range VLANs are actually stored in the VLAN.file in Flash. And the VTP, VLAN trunking protocol, is actually used to synchronize between switches. 1006 to 4095, the extended range VLANs, they are also in the running configuration. They are used by service providers. They support very few VLAN features and they require the VLAN trunking protocol configurations. Okay, so these are the, usually we normally work with normal range VLANs from 1 to 1005. So how do you create a VLAN? The configuration commands are pretty simple and straightforward. Just go into the global configuration mode, type in VLAN ID, give a number to it. Then you specify a unique name for that VLAN. So by using the command name and give the name whatever you want, and then you come back. So as an example, check this out. Now, if I want to create a VLAN in S1, what I need to do is I need to enter into the global configuration mode, and then I need to type in VLAN 20, which is the ID for the VLAN, and then I have to specify a name for it. I need to type in name student and then end. If you do not name it, the Cisco iOS will give it a default name of VLAN. Generally, it will usually give VLAN 0020 for VLAN 20 if you do not specify a name for it. After doing this, what we need to do is we need to give the port assignment commands. Very important. You create a VLAN by just assigning an ID to it and giving a name to it. After that is done, the interface to which this VLAN is connected to has to be configured. For that, you enter into the interface mode, interface using interface ID. Then set the port to access mode using the command switch port mode access. You have to specify, and then you assign that port to the particular VLAN you just created. Switch port access VLAN and the ID that you want to that you created, and then come out. So let me go back to the example that we just discussed. If you see here on S1, F0/18 is the port number to which PC2 is connected to, and PC2 belongs to VLAN 20. So in that case, I go into switch, type in configure terminal, and then I type in interface F0/18. Then I have to type in switch port mode access, and I'm setting the mode to access mode. After that, I'm saying switch port access VLAN 20. So for this interface, now it will be able to access traffic from VLAN 20. So these are the commands that we need to do. Now, what if, let's talk about for the data on voice VLANs. As I told you, one access port can be assigned, let me put it in these terms. An access port will only be assigned for one data VLAN. So one access port, one data VLAN only. But it can be assigned to one data VLAN and one voice VLAN. So if you see here, the same thing. If you want to set it up, type in VLAN 20. You have to name the VLAN, name student, and then we have to create the voice VLAN also. So VLAN 150, name voice, and then exit. After creation of these VLANs, what we have to do is we have to enter the interface mode. So go into the interface F0/18, which is here, and then switch port mode access, switch port access VLAN 20. And this is for your VLAN voice VLAN, MLS, QoS, trust, COS. This is setting up the quality of service parameters for your voice VLAN. You need not ponder much about it. Then you have to type in switch port voice VLAN 150 end. So these are the different set of commands through which you are assigning both VLAN 20 and VLAN 150, which is the voice VLAN, for a single port F0/18. Okay, so this is what you are actually doing this. Please remember one thing. For one port, you can only assign one data VLAN. You cannot assign two data VLANs. But for the same port, we can assign one data VLAN and one voice VLANs. Okay. Now, how do you verify what you have configured? For that, you use the show VLAN command. Now, there are multiple options for that. Show VLAN brief, show VLAN ID, then you will get ID, show VLAN name with the name, or show VLAN summary. If you type in show VLAN summary, you can see it gives you all the summary information, how many existing VLANs are there. And if you type in, if you see show interface VLAN 20, you can get actually VLAN 20 is up, whether it is set or not. And if you type in show VLAN brief, it will display the VLAN name, status, and its ports on one VLAN per line. And if you type in show VLAN ID and give the ID number that you created, it will display information about the identified number only. If you type in the name, usually the VLAN name that whatever you are giving is an ASCII string, and it can contain up to maximum of 32 characters. Okay. So what if you want to change the VLAN port membership? That means you want to change it to something else. You can simply do that by typing in the command switch port access VLAN, change the number. That's all. ID. So earlier you typed in VLAN 20, but now if you want to change it to VLAN 30 now, you can do that by simply re-entering switch port access VLAN here rather than 20, which you entered earlier. You just type in 30. Or if you want to default it back to VLAN 1, you don't want to have anything else. In that case, what you can do is you can simply type in this command, no switch port access VLAN. This, once you enter this command, it will automatically revert back to the default value. Now, once you do this, you can actually check out the show VLAN brief. You can check out whether it is done or not, whether it has been defaulted back or not. Or you can actually use the show interface F0/18 switch port command also to verify whether the changes that you made are reflecting or not. Okay. So if you want to delete a VLAN, you can delete by simply saying that no VLAN and ID, whatever ID that you created. If you want to delete all the VLANs that you've done, you can simply type in delete /VLAN dot or delete VLAN dat commands. That means all the file that is actually stored in the flash memory will be removed. But after doing that, you need to reload the switch again, so that it will purge each and every VLAN that is created. If you want to delete one specific VLAN, you just type in the no VLAN and give the ID command. That should do the job. So let's come to the point where we are going to talk about VLAN trunks. I told you what a trunk does, right? A VLAN trunk is a layer 2 switch, or say is a layer 2 link between two switches that carry traffic for different VLANs. So if you want to have a link configured as a trunk, it automatically means that the trunk is going to carry traffic that belongs to multiple VLANs. To enable, you have some set of commands. Now, first thing is you enter into the configure terminal on the switch, global configuration mode, then go to the interface which you want to set it up. But earlier when we had it for mode access, now we are trying to do is switch port mode trunk we are going to put it. Right here, the difference is setting it up to access mode earlier. Now, when you want to create a trunk, you need to set up the mode as trunk. Once you enter this command, switch port mode trunk, you are setting the port to permanent trunking mode. And then you can set up the native VLAN, switch port trunk, native VLAN ID. And if you want to set it up, if you want to set up the different VLANs that are actually going to pass through, you can type this also: switch port trunk allowed VLAN and all the list of the IDs. I'll show you with an example. Now check it out. The S2 supports multiple VLANs including 10, 20, and 30. But for this traffic to go out, it has to go through this link between S1 and S2, right? So I'm going to configure this link as a trunk link. Now for this, the set of commands that we need are, first thing is interface F0 by 1. I need to enter into this interface. And then I need to type in, here, this is the interface I entered. I need to type in switch port mode trunk. And I need to enter switch port trunk native VLAN 99. This assigns the native VLAN as 99. And because there are three VLANs here, I'm saying that switch port trunk allowed VLAN 10, 20, 30, and 99. Now, the same configuration has to be done on this particular interface on S2 also. That is the case. What happens is, now this link has been configured as a trunk, and it now has the capability of forwarding traffic that belongs to any one of these VLANs, 10, 20, 30, and 99. This is your trunk configuration. As I told you, we will be working on various packet tracer activities. For you to understand better, you have to go through the activities. You have to do them yourself. Only then you will have good expertise. How do you verify the trunk configuration? You can simply type in switch port, show interface, whatever interface you entered, and switch port command. Now, if you do that, it is actually, you can check it out. It shows you, there you go, it shows you switch port is enabled. It is the administrative mode is trunk now. And there it supports the .1Q encapsulation, and the native VLAN is actually set to 99. And trunking VLANs enabled is all the VLANs are enabled. So you have a lot of information when you type in the show interfaces, whatever interface ID you want to set it, and then switch port. This is how you verify the trunk configuration. Okay. So if you want to reset the trunk to the default state, what we can do is we can simply type in, use the no command itself. No switch port trunk allowed VLAN, no switch port trunk native VLAN. That means it will get back. So if you do that, if you see, access mode is VLAN 1 default. It reverts back to VLAN 1 itself. Okay, so native VLAN will be back to VLAN 1. So if you want to do that, you can simply use the no command, no switch port trunk allowed VLAN, no switch port trunk native VLAN. And after that, if you want to change that, or if you want to revert the trunk to the default state, you can simply type in switch port mode access. Once you do that, if you type in the switch port mode access command, it will revert back to access mode rather than the trunk mode. Okay, this is pretty easy. If you want to change it, you can simply, the one thing which you need to understand is, if you want to put it in the access mode, you got to type in this command, switch port mode access. And if you want to put it in the trunk mode, you need to type in switch port mode trunk. That's all. And the assigning of the VLANs is easy peasy. Now we have come to the last part, which is your dynamic trunking protocol, or in terms we call it as DTP. This is a Cisco proprietary protocol, which is actually used between devices to automatically negotiate trunking. It is on by default in all the Catalyst switches. Dynamic auto, there are different modes for this also. I'll show you the modes. If you see switch port mode trunk, and if you want to disable this, you can actually type in switch port no negotiate. If you type in this switch port no negotiate command, it will automatically disable DTP. Now, what do you mean by this? The switchport mode command that we are entering has got multiple options. These are called as the interface modes. The first one is the access mode that we studied earlier, which puts the link in a permanent access mode, and it negotiates to convert the neighboring link into also an access mode itself. If you need to put in a switchport mode access. If you type in switchport mode dynamic auto, it will become a trunk interface if the neighboring interface is set to trunk or desirable mode. So this is kind of a negotiation. Now one side of the link is access. It sets it into access mode, and it tries to convert the other mode also into access. If it is set to dynamic auto on one side, the link will become a trunk if the other side is set to trunk or in the desirable mode. If you set it to dynamic desirable, it will also try to become a trunk by negotiating with other auto or desirable modes. If you simply type in switchport mode trunk, that means you are permanently setting it into trunking mode, and it negotiates to convert the neighboring link into a trunk link. This is how. If you see switchport mode access trunk, if you type in dynamic, either you are putting it in as auto or desirable. Now the combinations, if you want to get a clear picture, this is how the combinations look like. If you see here, so dynamic auto, if the other side is dynamic auto, it comes into an access mode. If it is the other side is desirable, it puts it into a trunk mode. If it is trunk mode. If it is access mode. This is how the DTP negotiation takes place. So one side of the link and what is the other side of the link. Based on these two links, they negotiate, and they either go into a trunk mode or either they go into access mode. Sometimes one side is trunk and one side is access. The connectivity will be hampered. It shows that limited connectivity. That means it is misconfigured. Okay, so the default DTP configuration is dependent on the Cisco iOS version. If you want to find out what version you are using, you can simply type in the command show DTP interface at 0/1. As I said, usually in some cases you have to disable the DTP mode, but you can simply put in switchport no negotiate. That will automatically disable the DTP auto negotiation. We have come to the end of this particular module. As I told you, VLANs are purely based on logical instead of physical connections. They can segment networks based on users, devices, or applications. Each and every VLAN is considered a separate logical network. You have to keep remembering that. And a trunk is a point-to-point link which has the ability to carry more than one VLAN traffic. And VLAN tag fields includes the type, user priority, CFI, and VAD. This is called a tag, and the process of attaching this tag to a frame is called as tagging. A separate voice VLAN is required to support VoIP applications. The normal range VLANs 1 to 1005 are actually stored in the VLAN.dat file in the flash. An access port can belong to one data VLAN and also can support one voice VLAN, but one access port will not be able to support two data VLANs at the same time. A trunk is a layer 2 link between two switches that carries traffic for all VLANs. So trunks will need tagging for various VLANs, typically 802.1q. Now this is what I told you. IEEE 802.1q tagging makes provision for one native VLAN that will remain untagged. That means any untagged traffic passing through the trunk will be set to native VLAN. An interface can be set to trunking or non-trunking. This negotiation is actually done by your DTP. DTP is Cisco's proprietary protocol which manages the trunk negotiations. Now, I know that most of the students might feel a little bit complexity with VLANs, but once you start working with VLANs on packet tracer through all the activities, I recommend you to go through the NetAcad content, because you have got a lot of exercises, check your understanding quizzes, activity-based learning, where you can feel much more easier and much more simpler to understand VLANs. I will be preparing the videos for the packet tracer activities that belong to this module. Do check them out, and I am sure that once you start working on the packet tracer activities, you will understand a lot better about VLANs, and you will also feel confident with working on VLANs. So with that, let me take my leave. Thank you everyone for watching, and good luck. Thank you everyone.